Okay, right now we are on. And if someone wants to join us, let's just notify me. So I can check if I recognize them. Please, everyone. They'll ask you if you recognize them or ask them if you want to. What I want to do. Right? It's £5 grand. Give me £5 grand. This could be distracting. Never mind that. Sorry about Monday. The building was locked. I don't know that. I just believe the person I saw. You told me that. No, I do believe it. Was it you, Ricardo? No, someone told me the building was locked, and I believe them. It's fine. And I'm not going to make a YouTube lecture of that because we still have enough time to finish what we need to finish. Now, I'll be honest, when I designed the lectures for this course, sketches, mindful part, I kind of missed out on this extra week again. So I think if you look at the schedule, at least the original schedule, it says that this whole week will be revision, and I was thinking that there's no classes coming next week. So we have quite a nice buffer. We're not going to finish 4.5. We'll finish 4.4 symbol tables, and 4.5 will be home reading. In fact, I'm not saying this is the most fascinating, gripping textbook, but it's not bad reading. It's at least easy to read. And I find, if I didn't already know these applications in the details, I would read them. Why do you all have pieces of paper? What does this say? How to protest?
Yes.
I cannot believe this.
Yes, that Portland service.
It's plagiarism if you don't have physics 144. Maybe they're all plagiarized and now they have to sign forms to say they didn't. Who knows? Anyways, bottom line is that you're going to finish symbol tables. It's quite important. I read the rest. It's fascinating, but we're not going to do it in class. We are going to do this stuff because it's important to know, to understand symbol tables, at least the conceptual. I'm going to learn lots of other stuff. In fact, we've already learned about iterators in the last chapter, even though it wasn't the focus. What on earth are we going to learn this time? Just to recap very quickly, we said this is the interface we're going to implement for a symbol table. We can put keys, we can get keys, and we can put keys in the symbol table, you can get, or you can put an association between a key and the value in the symbol table. You can get back the value that you've associated the key with, or null if it's not there. And you can ask, does this symbol table contain an association for this particular key? You can't ask, what is the key associated with this value? It's a kind of two-way symbol table, and we will have a look at that as well. But the most important thing I wanted to mention is that these symbol tables are generic, so they have those angle brackets at the top, and you can plug in your own type. So you can have a symbol table that maps any kind of key to any other kind of value. And what's more is that last Friday we discussed what it means for the keys to be comparable, to implement a comparable interface. So it extends comparable key. So we're not going to do all that again. It's on the YouTube. And I haven't gotten around to putting the YouTube links on the website. If you've ever used YouTube, you can just search bar at the top. You can search for RW144 and you get this course. Also, I'm still struggling. Hello, no problem. I'm still struggling to regrade your assignments. So I finally took the plunge and said, even if it destroys all your marks, I don't care. I'm willing to risk it. So I thought I'd regrade. And apparently you can't regrade more than 4 or 5 assignments at a time. So I tried to I worked through all of you. I started at A, and I worked 4 at the time. I regraded every one of your assignments. Hello? I regraded every one of your assignments. Then at the end, I pulled the list just to check that the marks were still there, and I compared them with the old marks, and they were identical. So I don't know what the regrade did, but it didn't calculate new marks. So never mind that. I will fix it. I will get to it, and then eventually I will put up the YouTube links as well. I know how you people love those. Oh, you spend your weekends watching them over and over, excessively. Now, I'll talk about the test just a little later. But let's just get a little bit done. So, what do we talk about? Incomparable keys, yeah, we talk about them. Immutable keys. You don't want to put a string in the symbol table. And remember, you can't mute a string. But let's say you have some kind of object with fields. You add that to the symbol table as a key. So I have an instance of an object. It has fields, a method, but it has fields. Let's say it's a wrapper for integers. I think I did this in class. It's a wrapper for integers. Do I call it binteger? Yes. So binteger can store a value. It's just like an integer. No difference really. And now I'm going to use bintegers as the keys in my symbol table. I'm going to map bintegers to strings. So I give it a key, the binteger that contains 5, and I give it a string, the actual string, new string 5. Okay. And you look very gloved.
Sorry.
You look very gloved. I mean, it's like really depressing. Like, right. I map the binteger 5 to the string 5. More.
There's a question. When can you use implement? When can you use instead?
Oh, let's talk about that later. We have to talk about clearance. No. I'm mapping the binteger 5 to the string 5. So that's how we do it. And whenever I want to look up the binteger 5, I ask the dictionary get 5. Well, not that, of course, but that I say get, I pass the binteger 5 and I get back the string 5. But then somehow I change the binteger 5 to contain 6. But the symbol table still contains a reference that points to that binteger that used to contain 5 and now contains 6, and a reference to the string 5. And now I'm in a situation where I'm actually mapping 6 to 5. And my dictionary has been screwed up. I made some assumptions about my dictionary that it will map integer values to string values, and it would be the corresponding English string for that integer. But now that my bintegers can change, that assumption, that model of what my symbol table stores is no longer valid. So my program breaks, the space shuttle crashes, I am put in jail. So that's why it's very important to assume that the keys won't change. And you already know about immutable strings, immutable classes. Strings are immutable. Once you set a string to something, once you say string S equals, in quotes, 60, then S can never change. S can point to a different string, but that wasn't very clear. So let me explain this, because this is very important. This is conceptual. This is conceptual. It's not something technical. This is something conceptual. I've said that 3 times now. It ought to be enough. What am I doing? Not run. Make a class. Emat. It's emat, and I just want a little main. I just want to write some code. The code I want to write is string S equals ABC. Oh, shall I make an exam question? Yes, let's string. Oh, we all have that little tingling when you see an examination start like this. I know you're excited. I can taste it. Smell it, I mean. Consider the following variable declarations. You can really tell this lecturer is an asshole. Variable declarations, not even string declarations. Okay, fine. Now, what are you going to ask? Ooh. Well, what can I ask? Hello. Thank you. No problem. What kind of stuff can I ask? I can ask, consider the following surgeons. A, B, C, D. Oh, do it like this. Sorry, yeah. Which of the assertions are true? This is how we write all the exam questions. This is we speak out loud. A, and B. B, C, and D. C. A, B, and C, and A. Yes. You have 2 minutes. So let's fill in A, B, C, D. I mean, big A, B. S equals T. True or false? Who thinks B, big B is true? Keep your hands up. What do you think? It's false. You must put your hand up. Okay? See your hands up and down, so I can psychoanalyze it. Is that your hand? So we must all think, you guys are thinking. What's that guy's next to his name? Right in the back row. Yes. Who's number 1? Put your hands down. Who's number 1? Say your name. At the edge. No. Mark. A beautiful name. Moss. Oh, such a Gordo. That's a nice name, Gordo. Gordo, you didn't raise your hand. I was just worried. I mean, I don't want to offend. Maybe you're paralyzed, you can't raise your hands, and I don't know how you write. We have Cambridge students at Stellenbosch. Those students actually do very well because they work really hard. In any case, B is definitely true. S dot equals T for sure. They contain the same string ABC. There's no way they can't be equal. S equals T. I'm not comparing two strings. I'm comparing two references. R, S, and T pointing to the same instance of class string. Well, usually I'd say no, because it doesn't matter that the two instances have the same content. It doesn't matter that they have both ABC. You can have 50 strings that all contain ABC. It doesn't mean they will all be the same instance. There can be 50 separate instances. But before you ask, or tell me, before you tell me, in this case, it's a little different because I didn't calculate S and calculate T, and they happen to come to the same content. Oh my God, I'm supposed to talk about symbol levels. This is more important. I actually assigned them right from the start. I assigned S to be ABC. So what does Java do? It said, oh, how Yaku wants to assign this literal string to an S. So I'm going to make an object. But it's never new, but I'll do it for him. I'll new an object and have it contain ABC and point S to that. So S is a reference to this anonymous object ABC. But for T, the same kind of thing happens. It's a constant. Java knows about it before the time. It can make an object that contains ABC. It's immutable. So there's no reason why Java shouldn't use the same object it used before. It's basically the same thing as S. So I suspect the compiler is clever enough to have S be equal to T. And I suspect that A is definitely true. What about, okay, one for the easy ones. W equals S. Well, that's easy peasy. I'll be with you in a second. You just have to join the queue. First in, first out. Okay? Simply true that they're equal. And the last question is, yeah, that's fine. Okay. Now you wanted to say something.
Yeah. Okay, A is S. Well, do they compare it to references or do they compare it to values?
Equal sign, double equal sign. Double equal sign compares to values. And in this case, the values on either side of the sign are two references. So it's also comparing references. So the amazing answer to your question is both. Double equal sign compares the values that are on either side. And in this case, S is a string, so it's a reference to an instance of a class string. T is a reference to an instance of the value that's on the side. It are two references. I'm not being facetious. This is amazing stuff. So yeah, double equal sign compares two values. And in this case, the value on the left-hand side is a 3, and the other side is a 4. And if I had int x equals 3 and x equals, then it would be comparing x, which is the value, well, whatever that value x contains, and this 5. But as it happens, if I write big I integer x equals 3, what is Java doing? It's saying, okay, Yaku wants to make a variable that's an instance of class big integer. That instance will be called x. So x is referring to this instance. You want it to be equal to 3, but 3 is an int, and x is a big integer. So I'm going to box it for it. I'm going to automatically insert ghost code that instead of this, actually does this. That's what Java does for me in the background. And then, when it comes here, Java does the same. Or maybe it unboxes. Maybe it unboxes. Maybe it gets the value of x. I don't know how to get it. byte value, int value. So that's unboxing. You don't have to know this stuff. I mean, you have to know unboxing and unboxing, but you don't have to know this routine's name. But the bottom line is that Java either unpacks this int and leaves 5 as it is, and then it's comparing 2 values, or it boxes 5, and then it's comparing 2 references. Now, for integers, if you have 2 instances that are both equal to 5, then we have an issue, because now 5 cannot equal to 5 somehow. So for integers, it's critical that all big integer instances that contain 5 actually are exactly the same instance. Do you understand what I'm saying? Let me illustrate it like this. So now we're not dealing with boxing and unboxing. It's just 2 instances of a class that I'm creating. I'm checking if these references are equal or not. Usually Java compares the references for these 2 classes, and if they're equal, they're equal. If they're not, they're not. And usually, if I declare 2 variables, and I create 2 instances of those classes, which the variables are of, it would be create separate instances. The first new creates an instance over here of class big integer and sets it up by calling its constructor. And the second new creates a second instance over in a different place in memory and sets it up using the constructor. And now I have x pointing to where my right arm is called x and my left arm is called y. And comparing x and y will compare not the values inside the instances, but actually the references that my arms are pointing to. They're pointing to two different places, and therefore they're not equal. So usually, for most object classes, x would not be equal to y. That would be false. But for integers, especially for other numeric types, Java is clever enough to see that if you're dealing with integers, and you say, I want a new integer that represents 3, I want a new integer that represents 3, those instances must be the same instance. So x is pointing here, and y is also pointing here. Y is also pointing here. And it's not an issue because integers are immutable, like pointing to the number 3, but it's an instance that contains number 3. And Java is clever enough to say, well, this is true. Okay, right. Let's just move on a little bit. Yes, you want to ask or tell me something?
Well, I was just gonna, I wasn't sure if we reached a conclusion whether or not it was true or not.
I was just confused everybody, that's all.
Okay.
And I don't mind that. I don't care if you're confused, but I hope you sort it out. But you have, it's important to not just accept it, but to really understand it. Yes?
So the double equals with primitive types compares values.
Primitive type is values, but it's always values.
And with usually with objects compares reference.
Yes.
And now with s dot equals t.
Ah, that's something else. Now we're calling a method inside S that takes the t, which is also a string. That method is implemented to actually look at the contents of S and the contents of this t that we pass to the equals method, and actually compare character for character. That's what equals, the whole point of equals. Have you not worked with equals earlier in the school? You must have. So equals is really special, and that's why we have equals. So that for complex objects, I don't need equal sign, because that won't work. As I said, equals compares values, and those values may happen to be references. And if it's 2 separate instances, they're never going to be equal, because the references are different. One is located here. Remember, reference is just another name for address. So one's address is over here in memory, another one sits in a different place in memory. They cannot overlap, they cannot have the same address. So they're definitely different addresses, different references, and equals, which compares values or references, won't say they're equal. But sometimes I have complex objects that I've calculated that are equal, even though they're represented by 2 separate instances. So, for example, I can start in the game state initial game state, and do one sequence of moves. Let's say I do 10 moves and I reach a particular state in that game. That state describes, let's say, the board position, and I can't even remember what project you did, but some kind of board, I guess. There's a board. And now, starting at the same state, a very different sequence of moves, 20 moves, takes me also to a state. And those states happen to be the same. So now I've got two states that I created, but that describe the same board, that describe the same pieces and scores and whatever else is going on the board. What happened to Carlo? Is he So in that case, I can't just equals them. They'll be different because they're stored in different places in memory. I have to have an equals method that says, check if this instance is equal to this instance. And it will have knowledge of what the class exactly does. It will go through the board position by position, square by square, check that all the squares actually contain the same thing, check that the scores are the same, check that the music that's playing is the same, all that will happen. Okay, so let me, well, it's not exactly backtrack. Let's get back and start answering these questions. So, is S equal to T? The truth is, I don't know. And if it's an exam, well, you can't screw. It's a written exam, you have to know. I won't be asking you this in the exam, although I should. But I assume you've been assessed on this stuff. You know it so well that it's just boring you to not answer. But I would say A is true. I'm just going to guess. A is true, B is definitely true, C is definitely true, and D is definitely false. I was not clear enough to say, oh, after that addition or concatenation of U and V, you end up with ABC, and oh, I happen to see this thing before, I'll just make it equal to that. I don't think Java is that clever. Or maybe it is. So that's what I end up with. You're on your own when you have to calculate what's going on below you. I made that up. It's just a little joke. I was only pulling your socks.
We didn't even include C.
Whatever. Bothered. Okay, right. What the hell was I talking about? Equal signs. Strings. I can't even recall. Oh yes, immutable strings, that's what we were talking about. So it's very important to Java that the keys are immutable. In fact, there is an interface that we can use to enforce that they are immutable. To be honest, we can't enforce it in Java. Not really. So this interface is more of like a labeling. It's a contract, but it's an empty contract. Just almost, it's way of signaling to other classes that I'm trying to be immutable. There's no guarantees. Yes. Extends and implements.
Yeah. With the previous one, with W.
W.
So, yeah, the strings A, B, and C.
Yeah.
You said that W is equal to U plus V.
Yes.
And you said that V, W equals S is equal to false.
No, it doesn't.
Yeah, for V.
Let's call that W equals S. Because, I mean, otherwise you're going to get confused. I mean, that's W equals S.
Yeah.
That's W equals. Yes. W equals S. Yes. Well, let's make it, let's just change the name. Here we go. W equals S. Easier. Oh, never mind. Nothing I do is even good enough. Yes, what's the question?
I'm not quite sure why it's false, because the value of W is now AC, isn't it? Or is it not?
No, it's not. So the value of W is now a reference to an instance of class string. And as it happens, that class, that instance contains the ABC. But there's no rule that says that all string instances that contain the same value must be the same instance. You understand what I'm saying?
Yeah, yeah.
So you can have in memory many copies of class string, that all contain ABC. ABC, 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 ABC. And depending on how I arrived at those copies, they may all be separate instances. This is not true for integers. Because integers are so important to Java, boxing and unboxing is a natural part of Java, integers are handled a little differently in that if you have many copies of class integers that all contain 3, that's never going to happen. There will always only be one instance of class integer that contains 3. Java somehow enforces that. In fact, we can enforce it for our own objects as well. So we have programming. Reese, I'm trying to move on because I'm wasting so much time. Reese.
A is also false.
A is false. Oh, that's sad, but well, what can you do? Is it though? How do you know?
The referencing would be between the string object and the string object. So we said.
How do you know?
And our the program.
Now comes the really important question. How do you know that your compiler implements the canonical Java rule? It's just one compiler might choose to do that, and a different compiler might choose to do something else.
So under that logic, how would you ever know?
How do you ever know anything? That's really true. So you already know that Java actually has a really strict set of rules about how Java programs must behave. That's the canonical. Now, if we write our own Java compilers, we can deviate from that, which is bad. Which is the kind of thing that Microsoft would do. They write the Microsoft Java compiler. They would say, "Yeah, that's nice language, but we think a few of the rules have changed. It's got maximum chaos in the market." No. As it happens, I think most Java compilers are quite strict when it comes to the official rules. And I believe that your compiler is correct and that is false. So I'll believe that. Let's just do a few quick questions. Yes. Yeah.
When you leave a new string out, so if you say SS equals string ABC and T equals ABC, will they make new objects or will they point to the same?
Okay, now I'm going to say, I don't know. But if this isn't true, I'm going to eat my hat, my delicious candy hat. I can't find out in the shops, I'll make it myself. Eat all that delicious candy. Okay, right. Lise, what's the official word? True. Oh, excellent. Thank God, there's some logic, some fairness in the world. Okay, true. Fine. Let's move on a little more quickly. No one else wants to ask questions? Good. All feeling very sleepy and calm. Just quickly. Let's just do one more paragraph. Maybe I can get that far. Contains, no, crap, skip, variations, interval, yeah. Okay, right. Clients. No, but clients. So now the book launches into a long list of various applications that use dictionaries. They talk about experimental data, programming languages. The compiler uses a symbol table inside that's a critical part of how the compiler does its job. So that's very important. Genomics, looking up gene information, account information, dictionary, phone book. Yeah. Well, let's just agree that almost all programs use a dictionary of some kind, a symbol table of some kind. So they have a program called Lookup. I don't know what it does. They have very interesting data about looking up domain names and IP numbers, the mapping. So they keep a symbol table that's got keys that are strings, which will be domain names, and values, and values that are also strings that are IP numbers. Now they can store this differently. They can make a special kind of object that can contain an IP number, but let's not go into that. I had some other interesting data, but I think I've lost it. Was it your marks? What? No, it wasn't your marks. That would be a breach of confidentiality. But I think I somewhere put the marks for this course from like 20 years ago. I'm assuming those people are all dead, possibly. and that we can use their marks with kind of impunity. So, but I'll show that to you next time. This is an example, but I really want to get to 35. Yeah, we can do it. What I really want to get to is the actual interface. Oh, I've already written it. Okay, well, there we go. Now it's quite quick and easy. This is an interface for ST, for a symbol table. It's generic. I can specify what kind of keys I want to map to what kind of values. But there's one rule, and that is that key must extend class comparable key. Oh. So if you're confused by this, just go watch Friday's video. I think we eventually reached the point of clarity where we said that comparable key is an interface, it's a contract that says whatever implements this contract must have a compare to routine where it compares itself to a key value. So keys must be comparable to other keys. Basically, I can compare two keys. Why I'd want to do that, who knows. So let's write our first implementation. It's in the book. It's not a big deal. I'm going to call it array ST, and it's going to implement the interface ST. Oh, I haven't even done anything and already I have some errors. What's going on? It says key cannot be resolved to a type. And that probably has unimplemented methods, yes. So an array ST is going to satisfy the contract ST that maps keys to values. But what kind of keys am I going to map to what kind of values? I can't specify ST without specifying what kind of keys and what kind of values. So we either have to decide that array ST is going to map strings to strings, or we have to kind of pass the buck. And I'm going to pass the buck. I'm going to say array ST itself is a class that you can give parameters to, which makes a lot of sense. Key and value. So when you declare a type, an instance of array ST, you supply a key and value. And this class definition uses that to say that, okay, well, with this key and value, array ST will satisfy the contract ST key for this key and value. It's like passing a parameter. But now there's a little issue because this key extends the comparable interface. This key doesn't, so I kind of have to fix that. Will Java do it? No, Eclipse won't do it for me. So I will have to say extends comparable key. And now everybody is happy. Except for the missing routine, but that's fine. It'll come in a second. One little note, just to say that again because it's worth saying again. If you have a class, let's do it up here. I'm going to have a class A, it's not very exciting. Class B, not very exciting either. Interface A and interface B. Okay, let's have those definitions. How can they be related? If I declare a new interface, like ST, that was an interface, a contract. Interface, I'm going to call it AB. Java's very happy with that, no issue whatsoever. Oh, it's complaining because I've got duplicates. I'm so sorry. I'm going to call this IA and IB. I'll call that CA and CB. Give me one sec. Interface IIB. Okay, right. I've got interface IIB. That's fine. I can also say that interface IAB is an extension of a different interface. It extends IA. So IAB is a contract, an interface, that is an extension of a different contract. It asks exactly the same as IA, plus a little more. It just adds on a little more. In fact, I can extend more than one thing. I can say IA, the interface IAB, is a contract that is the same as the contract IA and IB. It extends those two contracts. It has exactly the same as IA and a little more, and it also contains IB and adds, well, it doesn't have to add, but it could add a little more. So when it's an interface, it can extend other interfaces, and it can extend more than one. Let's see what happens if it's a class. Let's see, I'm now writing the implementation for a particular class IAC. And we know that we can write only that, that's fine. Java doesn't mind. But I can also say it extends CO. Why what? No, man. I want to call it CAB, class AB. Yes. I can also say it extends CA. What does that mean? Well, that's called inheritance, my friend. So that means that CAB takes on all the fields of CA and all the methods, all available inside CAB, and I can add some more if I want. I can also override some of the methods. So that when you call method XYZ, in class CAB, we'll actually call the CAB version of the method and not the CA. Can I extend more than one class? Well, very subtle, but there is a mistake. Okay, it's just the comma it doesn't like. Syntax error. Didn't expect the comma. Point is, I cannot extend one class, cannot extend one other class. Very deep theoretical reasons for that, but basically that's called multiple inheritance. It creates all kinds of issues, and in Java it's not allowed. In other languages it is, some other languages, but not in Java. So one class can only have one superclass. Now I'm going to speed up a little bit. I'm going to say about interfaces. CAB can also implement different interfaces. It can implement IA, but it can also implement IB, and it can also implement IAB. So it can implement as many interfaces as it wants. All it means is that this class will definitely satisfy the contract specified by IAB. Right, let's talk about the test. Many people have sent me emails about the test. Ricardo, he sent me several. Is that true? None. And I'm shocked. Right. It will be in the engineering building on the 3rd floor, but I forget the exact rooms, and I will put them on the web. 303, 306. Roughish. Okay. There may be protests tomorrow, so bring your student cards and come 15 minutes early. It's a written test on paper. It will deal with stacks and queues, but not exclusively. So the idea is to assess you on that, but I cannot help but also assessing you somewhat on what has come before. So I may ask you about sorting, I may ask you about searching, I may ask you about performance. You understand that? Yes, please.
For example, write the code when it's search and sort.
I wouldn't ask it like that. I would ask, write code that sorts this queue or stack.
But then,
So it's a little like that, but
please give us space so we can write on that implementation. Because in the past papers, it was like one line.
okay, so you're saying that I must leave enough space. I'll do that. Okay. But if there's only one little space, it usually means that the answer is expected to be short. It's usually a clue. The short answer is expected. So I'm not going to ask something like write your name and give you 2 papers. That, basically. Okay. So don't stress about the test. You've done so well in the past that I feel that I can award you somewhat and not make it super difficult. The idea of continuous assessment is not that you study every night for every new test. The idea is that you study normally, you are assessed, study normally, you're assessed. We're trying to get away from this whole idea that there's one big exam at the end. Nobody learns anything until the day before the time. They really study hard for the exam, write the exam, and forget everything exactly. So it's like knowledge goes like 0, one little spike, not even very big, one little spike, and then back to 0 again and carries on. So the idea of continuous assessment is for you to learn things in class and then start forgetting it, and you're assessed, and you learn more things. You're assessed. So it's not, you're not supposed to study real hard for all these little continuous assessment tests. So I'm not going to make it real hard. Gesundheit. Lastly, test tomorrow. Apart from that, all the normal assessments are over. And the only thing that's left is the exam timing test, which is a makeup test. You can only write that if you have an average for written tests below 50. So if you have 49, you can write that. If you have 51, you can't. Because we need to be fair, you can't score more than 50. You can't get a final mark more than 50 in the, or average in the written exam either. Yes?
Do you need an average of 50 for the written test? Because the course outline says you need 40 for the written test.
To pass this module, you need an average of 40 for the written test. So there are only 3 kinds of people in the world. That's what my mum was. Bless her soul. She said those people who have below 40 average on their written tests, they must definitely write the exam. They qualify, they can push the average up to 50. Otherwise, they won't be passing the course. Then she used to say, and Yaku, there are also people between 40 and 50. Those can write the test if they want to. They have already passed, at least that requirement for passing the module. If they want to up the mark up to the heady heights of 50, they can go 60. People above 50, stay away. You're not allowed to write the makeup exam. Okay? If you do, your score will automatically reduce back down to 50. Okay? So you can't D score, you can't N score. Quickly.
Does the test replace one of other blocks?
I don't know how the hell we'll do it, but the bottom line is that it's so that if you are either ill or you are not passing the module, you have a chance to up your average to 50. So however way we cheat, it'll be the average that goes up to 50 or stays where it. Yes?
Does it mean that the cap is for the written test only, or is it for one mark?
No, it's only for written tests. I'm so sorry. Yes.
So the cap is you have to get 100% square.
Did the captain say you get it out right?
So
Yes.
Do we have to get 100% just to get?
I wouldn't think. Oh man, now you're pressing me on how exactly we're going to make this work. So I would say what we do is it will replace your lowest mark. We'll calculate your new average. If that's above 50, you just cut it off. So you can only end with new average for the written test of 50. And we'll cap your test score so that that comes about. It replaces your lowest mark, and if the new average is more than 50, we cap your test score. Okay, we have to go. I have to go because I've got an important coffee to drink.